Well, hello there. Welcome back, everybody. Man, it's been a long time. That was a long spring break. You know, the joke is everybody's saying when you guys come back on Monday, some of you, that was the longest spring break ever, right? Because they're including all the time. It was since March 13th, Friday the 13th of 2020 was the last time we had kids here in school in Windsor. So anyway, hope you had a great time. Hope you're ready to get back in it and make that push for the end of the quarter, end of the semester, end of the year. It's gonna be seventh graders soon. This is crazy. All right, missed you guys. Let's go ahead and do this. You know the drill. Copy down the warm up, right? And you want to press pause and go do as much as you can, then come back for hints or come back and check your answers. Either way, right? We'll see you in a bit. I'm looking for a red pen. The top doesn't pop off. Here we go. Let's get going on this. Most famous diamond ever, 42 and 13. Remember how it works. The product goes on top and the sum goes on the bottom. And what two numbers have a product of 42 and a sum of 13? That's going to be 6 and 7. Most popular diamond ever. How about 100 for the product? 29 for the sum? Well, 4 times 25, 4 quarters, right? 1/4 and 1? Yeah, doing fractions. 1/2 plus 1/2 is 1 whole. And 1/2 times 1/2. Remember, multiplying fractions is what? Did you forget? Did you forget? Multiplying fractions is easy. Say that when I say it. The more you say it, the easier it'll get in your brain and stick. That's what we want. Things we learn to stick. So why is multiplying fractions easy? Because you don't have to worry about denominators and stuff. You just go straight across top, 1 times 1, straight across the bottom, 2 times 2, right? Numerator's product is 1. The denominator's product is 4. 1/2 of 1/2 or 1/2 times 1/2 is 1/4. About 1/9 and 2/3? Another easy one, right? Well, it was easy before the break, huh? You took so long to get back to us that you forgot all this stuff. No, you didn't. It's in there, right? You just got to tap it, all right? It's at the back of the shelf now. You got to move it out front again. All right, exponents, 4 to the second power. Most popular wrong answer is 8, but the real problem is 4 times itself. 2 times 4 times 4. 16. 4 squared is 16. 2 to the 4th is not going to be the same thing, right? Or will it? Right? It is not 8. It's 2 times 2 times 2 times 2. And actually, when you do 2 times 2, you get 4 times 2 is 8. And 8 times 2, 16. That's one of those weird ones that is the same thing. That's rare. In fact, I don't know if there's any more that do that. You have to find it for me. Okay, find one that works like that for me with a reverse. All right, 6 to the second power, 6 times 6, 36. How about another one? 9 to the second power, 81. 5 squared is not 10, it's 5 times 5. And 1 to the 15th, 1 times 1 times 1 times 1 times 1, how many times? 15, so it's 15, right? No, it's going to be 1. No matter how many times you times 1 by itself, it's going to remain 1. 10 to the 6th power, what's the trick? Well, powers with 10, right? Is going to be a 1 with that many zeros, right? 10 to the first power is 10. That's 1 0. 10 to the second power, that's 10 times 10. That's a 1 with 2 zeros. 10 to the third power, 10 times 10 times 10, that's 10 hundreds. That's 1,000, 3 zeros. That pattern continues. So I'm going to have 6 zeros. Go back 3, go back 3. So 10 to the 6th power is a million. How much money you owe me if you don't finish this year strong and get an A or B. Okay? You need help with that, you ask. Perimeters, when you add up all the sides all the way around that side, you're building a fence around that field. Okay? 6 meters and 18.2 meters and another 6 and another 18. So it's not just that 24.2, but it's 24.2 doubled, right? Because that gets me halfway around. 48.4 meters, right? How long is the fence? Meters. Now, to get the area, you're multiplying. Right? It's a rectangle, so 6 times 18.2. Pretend like it's just 182 and do 6 times 182. That's the first step. 6 times 2 is 12, and 48 and 1 is 49. Carry that 4, and then 6 and 4 is 10. So 1092, but I pretended that was 182 instead of 18.2, right? Pretend it was a whole number. I'd move that decimal one spot to the right. So I have to go back one spot in my answer. So 109.2. Now, we talked about another way, and that's square meters, of figuring out where that decimal goes. The other way is when you just estimate. When I estimate 6 times 18.2, I'm going to say that's a 6 times 20. That's 120. If my estimate is 120, it only makes sense to put the decimal there. If I put it here, it's 1,000. If I put it there, it's 10, right? So if my estimate's 120, 109.2 is the closest to 120, okay? Another way of figuring out where the decimal goes is to estimate sometimes. Try that. You should practice your estimating anyway, because in real life, like I say, most of the math you're going to do is estimating. You want to get good at it, okay? Not just so you can get it right on a test. You want to get good at it for life, okay? Now, the perimeter of this parallelogram is going to be 11.2 plus 14.3 plus another 11.2 and another 14.3. Now, I made these numbers what we call compatible. Line up those decimals when you added the decimals, right? Decimals should be one on top of another. And I get 25.5. Now that's halfway around. That's like from here to here to here, but I want to go there and there too, so I'm going to double that. And I get 51. Okay, so I can drop that 0 since there's nothing else after the decimal. So the perimeter here is 51 feet. Okay, again, to get the area of a parallelogram, you care about that 9. How tall is it? You don't care about that anymore. How tall is it times how wide is it? That's the parallelogram, the area. They call it the base times the height. Okay, here for some reason they call it the length and the width. I don't know. I don't make up the rules. I think they do it just to confuse you. They want to make you strong mentally, right? So then test you by trying to confuse you. But you got that, right? All right. And again, almost all the time when you're doing the area, you're looking for the two lines that make that right angle. Okay. Now a rectangle, all of these are right angles. Okay. Triangle, it's these two for the area. Okay. But there's another trick there. So I'm going to go 9 times 14.3. Pretend it's 143. 27, 36 plus 2, 38, and 9 plus 2 is 11. Whoop, 38, 12. All right, so 1287, but I'm going to move the decimal over one spot, 128. Now, again, if I didn't know to move it one over one spot, and I just estimated, I'd say this is like 10 times 14 is 140. 128 makes the most sense. Okay, so area is 128.7. What are my units? Hopefully you're saying square feet. Area is always square units. All right, the perimeter, I need these 3 around the outside. I don't care about that 18. So let's line up the decimals when I go add them. And again, I don't know if you notice, I put the decimal down as the first part of my number when I put that second number down. Okay, now where's the decimal here? Don't put that 32 like this, right? There is no decimal, so you would put it here if you didn't know. Okay, put that decimal, the 32 goes over here. Now I can fill in a 0 after that decimal if I want, so it doesn't look so weird. Okay, but 2 and 8 is 10. Decimal comes straight down. And 1, 2, and 2 is 5. And 2, 2, 3 is 7. 75.0 is my perimeter. And I'm just going to say 75 inches. Okay. Now the area, I'm doing 18 times 32, but that would be double my area. Remember, for a triangle, you got to cut it in half, because this would be the area of this parallelogram, right? Which is 2 of these triangles. Okay. How wide it is times how tall. Now I can do 18 times 32, then divide it in 2, take half of it. But the trick here, the easier thing to do, is just to take one of these numbers and take half of it, times it by So I'm going to go ahead and, since I get one digit, if I take half of 18, get 9, and do 9 times 32. Now that's 9 30s, 270, and 9 2s, 18. So I'm going to get 288 there. See how I did that? You kind of do it in your head. It's called distributive property. Okay, how does that work? It's kind of like when you make a generic rectangle. And instead of just doing 9 times 2 and the standard algorithm like we could have done there, I break up the 32 into 30 and 2 because once I have a single digit with zeros, it doesn't matter how many, it's a basic fact. This is 9 times 3, right? 9 times 3, and then with a 0, right? Or with 2 zeros, or with 3 zeros, depending on how many, and 9 times 2. So that's kind of what I did. I did 270 plus 18 because that was easy to get 288, okay? And I don't have to cut that in half because I already did. I cut the 18 in half. And you say, but Mr. Daniel, what if instead you took half of the 32 and did 16 times 18, okay? And again, that might be one that some of you can do in your head because 16 times 16 is 256, and 2 times 16 is 32, so 288, right? Now, let's go ahead and do the standard algorithm on that. 6 times 8, 48, and 6 times 1 is 6 plus 4 is 10, put a placeholder, and then 1 times 18 is 18, and then what do you get? Same answer, okay? Now, this is kind of weird, though. If you didn't have Mr. Daniel or didn't memorize 16 times 16 like Mr. Daniel's students, you would never do that. Split that 18. It's kind of like what you did here. Is you split that 18, instead of a 10 and an 8, you did a 16 and a 2. Kind of cool. Yeah, you don't always have to use round numbers when you do that, right? Do what makes it easy. Okay, done with the perimeters and areas. Now we're on to of. What does of mean in math? You remember? Put a big X through it. And multiplying fractions is easy. 3 times 4, 8 times 9. And guess what? 12 goes into both of those, right? 12 goes into the top once. It goes into 72 6 times. Now, could I have made that easier? Remember cross-canceling. If a 3 goes into the top and goes into the bottom, I can simplify saying 3 goes into 3 once, and it goes into 9 3 times. 4 goes into the top and goes into the bottom. 4 goes into 4 once and goes into 8 2 times. So on top, I have 1 times 1. On the bottom, I have 2 times 3. Cross-canceling gets you smaller numbers to multiply, and then sometimes you're able to do it so much that you don't have to simplify when you're done. Okay, here I had to figure out that 12 went into 72. Now, if you know that, it's all good. Okay, but just know that cross-canceling is a pretty cool trick. Okay, who remembers how to divide fractions? 7/10 divided by 1/2. Give you a hint, Miss Nortz, right? Remember, Mr. Cannon taught me to say, yours is not to reason why, just invert and multiply. And Miss Nortz said, you know what? Sixth graders are going to remember my way better. My way? Smell my feet. Smell my feet. Remember, the first number stays the same. Don't mess with that first number. 7/10 is 7/10. And I'm going to multiply instead of divide because multiplying fractions is, hopefully you yelled out, easy, right? Yeah, back in school. And then that F, instead of 1/2, I'm going to flip it over and go 2 over 1. Now I have 14 over 10 when I multiply, and 2 goes into the top and bottom. 7/5 is the same as 1 and 2/5. Okay? Now, if I did that real fast, go back and put me on slow motion. Okay. No. Yeah, check it out. That's the nice thing about having a video. You can rewind if you want to. Right? All right. Now, what do we want to do here? We can use the generic rectangle on this, or we can use the C method. All right. Remember, I can change this into an improper fraction. 4 times 5 is 20 plus 1, 21/4. 3 times 7 is 21 plus 1, 22/7. Okay. Now, before I multiply, 21 times 22. Remember what we were saying? You could cross cancel. 7 goes into 21. So 7 goes into 7 once. It goes into 21 3 times. I've just made this easier. But both of these are even. 2 goes into 4 2 times and goes into 22 11 times. So on top, I have 3 times 11. On the bottom, I have 2 times 1. And all I have to do now is divide the bottom into the top. And 2 times 16 is 32 with 1 left over. 16 and 1/2 is 33 halves. See how we did that? All right, almost done here. To subtract here, you want to write one on top of another. And then don't just bring down, don't say 16 and 2/7 here. I got to take that 2/7 away from something. So I'm going to cross out that 18, make it a 17, and get myself one whole, which is how many sevens? 7 sevens. So now I say 7 sevens minus 2 sevens, and then 17 minus 2. And hopefully your 5 looks better than that 5. Okay? Don't tease them. It was my fault. All right. 3 1/8. I need a common denominator. 8 goes into 24. 3 times. 1 times 3. 1/8 is 3/24. 6 goes into 24. 4 times. 6 times 4. 5 times 4. 20 plus 3 is 23 24s. And 3 plus 2 is 5. Okay? 6 1/4 minus 5 6. Okay? Now, I'm going to 24ths again. Now let's go to 12ths. 10 12ths and 3 12ths. Looks like I'm going to have to borrow. Now, don't put a 1 in front of that 3. I borrowed 1 whole, and I got 12 12ths. I had 3 plus 12 more. Now I have 15. 15 minus 10 is 5 12ths, and 5. Okay? Now, what does this mean? That's divide. All right? You divide the bottom into the top. Okay? So 6 1/4 divided by 5 6. I'm going to change that 6 1/4 C method to 6 times 4 is 24 plus 1, 25 fourths divided by 5 6. And then I'm going to smell my feet. Okay, so that first one stays the same, 25 fourths. I'm going to multiply instead of divide because multiplying fractions is easy. And then I'm going to, instead of having 5 6, I'm going to flip it to 6 fifths. Okay, and then I could multiply straight across the top. 6 quarters is $1.50. 4 nickels is 20. And then say 10 goes into the top 15 times. 10 goes into the bottom 2 times. And say 15 halves is the same as 7 and 1/2. Okay? All right, 12 over 1. Smell my feet. This is 7 halves. Multiply, and then instead of 7 halves, I'm going to 7s. 24 over 7. When I divide 7 into 24, that goes 3 times. That's 21. And my remainder goes on top. My divisor on the bottom. 3 3/7. You are done with that long warm-up. Man, I just went off on a tangent back there, didn't I? Okay, welcome back, everybody. I promise tomorrow's warm-up will not be that long.